And here is unit 42. It's a very short unit and it is not difficult, just in case you got a good memory. Now, first of all, so what is meant by transition metal? Well, that is some metal between group 2 to group 3 started from period 4. So let me write down. That is started from 21 scandium, and in DSE we only focus on those metal in period 4, so don't worry. The reason why we spend time to discuss it is because if you still remember what we have learned in unit 41, a new term called effective nuclear charge, transition element are similar effective nuclear charge for all these 10 elements. So the conclusion is they have similar atomic size. Let me explain to you what's going on. Still remember the number of electrons in shell is actually governed by an equation called 2n squared, right? For period 4, for the third shell, well actually they can accommodate 18 electrons according to this equation. But these 18 electrons are not in same position actually. I can just call them team A and team B. Team A got 8 electrons and team B, which is something new for you, can accommodate 10 electrons. But these 10 electrons normally will not appear. That's why after 2AA, the next one is 2AA1 for potassium, because they try to fill in the fourth shell first. But after calcium, 2AA2, the next element will try to fill in this 10 electrons position. So you can expect from 21 to 30 in the periodic table, their outermost shell still fourth shell, but in the third shell, more and more electrons are filled. That means on the surface, no one noticed that what the difference they are. Only those people study the inner shell can understand which element you are talking about. And here I can give you the truth, right? So you can see actually most of them got 2 electrons in the outermost shell. Their only difference is actually in the third shell, which is the inner one. Alright, so this is a signature of transition metal. Is all of them got the same outermost shell electron, but not the same in inner shell. So let's write it down. The new coming electrons are added in the third, which is the inner shell. Let's see the general properties of transition metal. The first one is compare with main group metal. For example, group 1, group 2, and group 3. They are hard and strong, yes. So you can expect the hammer and nail are made of iron because they are hard enough. They are not possible to be made by, for example, sodium, because sodium is so soft, right? Next one is, okay, titanium. So you have learned that used to make hip joint because they are biocompatible. What about copper? Copper, they used it in making electrical wire because high conductivity. And finally, chromium is used to make stainless steel. Yes, I'm sure you can give more and more examples. Compare with the main group element, the transition metal. Now please pay attention. They got the following properties. First one is high melting point and boiling point. The second one is high density and hard and rigid. So as I mentioned, because they have similar atomic size, so their properties will be similar. And because some case they will use more and more outermost shell electron in forming the metallic bond. So That's why they got stronger metallic bond than those main group elements, because in some case, those electrons in third shell can be used. Again, no need to memorize the number, just give you an impression. The melting point between transition metal and main group element. So you can see, even for calcium, still almost half to that of cobalt. But I'm sure this is not something very interesting for you. So let me say more. There are 3 general properties. Now, these 3 general properties is a must. Remember, otherwise you cannot get any mark. It's extremely important. First of all is, most of them can form colored ion in aqueous solution, especially. You can give plenty of example, right? Copper 2 is blue, iron 2 is green, cobalt 2 is pink, whatever, okay? The second one is, they got various oxidation state. That means more than 1 oxidation number is allowed. Iron 2 and iron 3 is a good example. The oxidation number of iron can be positive 2 or positive 3. This is not allowed in group 1 or group 2 element. The third one is, they show catalytic properties, serve as a catalyst. Again, those main group elements, sodium, potassium, they can hardly be a catalyst. But don't worry, the reason behind is out of the syllabus, so just memorize is enough. Well, next one, I will show you some colored ion. No need to be panicked. Try to write down as much as you can. So you can pause the video first. Here shows. I'm sure you learned this already, right? The cobalt 2 got pink color is in aqueous solution. When there is no water, cobalt 2's color is blue. That's why the cobalt 2 chloride can serve as a water indicator. And chromium 3, no problem. Dichromate, no problem. Nickel 2, copper 2, no problem. Now, there is something new for you, is titanium 3 iron. Okay, I just tell you, it's violet in color. So I think this is easy for you to memorize, right? Yes, you need to memorize this. And next one is, there is a bit difficult. So again, there is something about how can a substance become colored. Here shows a what we call is the color wheel, okay? Those students who study visual arts, they will use a lot. All we know that the white light is actually composed of more or less 7 colors. When they combine, they will form white color. But for example, if a substance just absorb one of these, for example, absorb red from sunlight, after red light is gone, so what color it will be? Yes, the color wheel will show you that it will become green. For example, the chlorophyll in the plant, actually the chloroplast absorbs red light. That's why they appear green under sunlight. And don't worry, because we are not visual arts students, so just approximately is okay. No one asks you how green it is, what type of green it is. It is meaningless. We don't care. So the color wheel can give you the complementary color. That means if one day we know that what color the substance absorbed from sunlight, then we can get a conclusion is what color it appears to be. Now, here shows a typical example, the copper 2 sulfate solution. I'm sure everyone knows what color is it, right? It shows you blue color. Well, according to the color wheel, if the substance belongs to blue, that means it will absorb orange. Let's check for the absorbance among different colors. So you can see this is violet, just like a rainbow, and this one is red. The copper 2 sulfate solution just showed you it absorbed most in The orange region, this is the absorbance. Once the orange color is absorbed by the kappa 2 solution, only blue light is transmitted. And that's why it shows you blue. Let's write it down. The radiation, mainly in orange region, is largely absorbed, and only blue region is transmitted. That's it. Now, let's see what type of questions you will see in the public exam. Question 1, let's do it together. Which of them is an atom of a transition element? A, sure, no, because the number of electron or number of proton, it depends on how you see it. It should or started at 21, right? But A is 20. 20 is calcium. Surely not the transition metal. C and D, no good. Because if the element is in C or in D, then I can call it group 4 or group 6 immediately. Transition metal do not allow the outermost shell electron beyond 2. So have a quick revision here, right? They are either 1 or 2 at most. So sorry to say, C and D, no, because we can find their group number, right? So all you remains is boy. There's nothing special, right? The next one is you compare the melting point of transition metal and the number of oxide found in nature. First of all, assure D is not, because the melting point of D is too low, right? It is not possible to be a metal. Alright, A is also not correct, because if this is a transition metal, how come there is only one oxide here? So only B and C are the possible answer. And I'm sure you know that B also incorrect, because for a transition metal, this is no point for such low melting point. So the answer is C. Not so difficult, right? Just follow what we have seen in the notes and you can get the correct answer. Next one. Which one will give you a purple solution? Now, let's check. The first one is titanium 3. The second one is iron 2, Mn2 plus, and Cr3 plus. So I'm sure you get the answer, because the others are not in purple, right? Iron 2 is green, and Mn2 plus is colorless or pink, chromium 3 is green. So none of them appear as purple. This is not difficult for the questions. First of all is about the colorless solution. The second one is about the oxidation state. Here shows, first, again, no need to spend time in memorize this table, okay? Forget this. All I can tell you is, first, for a metal ion with lower oxidation state, what is meant by low is positive 3 or below. It's called lower oxidation state. They found it as simple ion. That is, only a metal atom become a metal ion. That's it. Nothing more. But for those with higher oxidation state, they are formed in covalent compound. Well, maybe you don't understand. Well, that means they bonded with oxygen or polyatomic ion. Alright, so some of you may wonder, how come the transition metal combined with oxygen will be covalent bond? Oh, that is something very difficult to tell you. So it is beyond the syllabus of DSE, so I try to skip it, okay? So you just memorize lower oxidation state is simple ion. Higher oxidation state is polyatomic. That's it, simple. The second one is, for those with higher oxidation state, they will be good oxidizing agent. Of course, because oxidizing agent will try to lower their oxidation number during the process. For example, for the permanganate, they turn into Mn2 plus from positive 7 to positive 2, they always want to drop the oxidation state. That's why a high oxidation state should be needed at the beginning of the reaction. Well, next one is for those only have one oxidation state. Okay, I agree that there is some special case. These two elements only got one oxidation state. They are a bit extreme case because they don't have more than one oxidation state. So they don't have a signature properties of transition metal. Their ions are colorless. Alright, so in the following section, I will try to use two elements to be example. We choose vanadium and manganese. Now, please write down the oxidation number of vanadium in all these four compounds. This is nothing difficult for you, right? And next is the color. You can get it from the picture. It's yellow, blue, green, and violet. Here, I give you a method to remember the color of vanadium. So, hope this can help you to memorize color corresponding to the different oxidation state. So you can see when you add zinc inside, they turned from positive 5 to positive 2. So what is the function of zinc? Yes, some of you get the answer is as reducing agent. And we are not happy with that. So again, this is a quick revision for you to the use of electrochemical series. But this time, I got something new for you is the reaction may not end in single step. Multiple steps will be expected. Here shows. Started from this one, positive 5 oxidation state. Here, and we got zinc. For the first reaction, zinc become zinc ion. Remember? Anti-clockwise relation. Zinc becomes zinc ion, and VO2 plus become VO double plus. Nothing special, right? From positive 5 to positive 4. Very good. But something new here. The reaction hasn't ended because VO double plus is here. It allows the second reaction with zinc. Zinc becomes zinc ion again, but this time VO double plus become V3 plus, positive 4 to positive 3, right? From blue to green. And finally, V3 plus is here. So again, in case there is zinc, V3 plus become V2 plus. In unit 42, all you need to learn about electrochemical series is the steps are multiple, more than one step involved. So please keep in mind, okay? Next, what is the checkpoint? So which one is correct? Oh, okay, don't be silly. Chromium 3, of course, not orange. Iron 2 won't be yellow-black. Nickel 2 won't be pink, right? So the only possible answer is D. Maybe I forgot the color of V3 plus, but I'm sure not the other one, right? Next, you can see ECS is always given, as I mentioned in the notes or in the lesson, right? Or question A, VO double plus shaken with tin in acidic condition. Let's find it out. Tin is here. VO double plus. Now, we got two VO double plus here. Orange one or the pink one. So which one is possible? Yes, this one failed. The pink one failed. The reason behind is if both of them are reducing agent, right? Still remember, this is OA, this is RA. If both of them are reducing agent, then how come we can start a reaction, right? So no. Next one is our anti-clockwise relationship here. This is, okay, keep in mind, this is first step. Okay, this is first step. V3 plus also appears here. So my question is it there further reaction between V3 plus and zinc? The answer is no, because you can see the green one, it is not possible for the V3 plus have anti-clockwise relationship with the tin, right? If they have anti-clockwise relationship, then something will like this. Surely this is not possible, right? So the reaction stopped at V3 plus. So let's double check. V3 plus is green. So here is our answer. Next one. Oops, we have VCl2, but that is V2 plus, okay? Don't worry. It's left in an open beaker for a long period. Well, that means react with oxygen, oxidized by air or oxygen. If you don't believe, just read what you have. In this ECS, suddenly there is a O2 here. So if there is no reaction with oxygen, how come they put this equation here, right? V2 plus is here. Oxygen is the green one. So let's see. V2 plus become V3 plus. Oxygen become hydroxide. Oops. But the story hasn't ended because V3 plus also here, right? So they will get further reaction. This is step 1. This is step 2. Become VO double plus. Is there any step 3? VO double plus also here. But sorry to say, the purple one cannot draw the anti-clockwise relationship with O2. So only step 2 is allowed. VO double plus is blue. Because maybe you can write down V2 plus become V3 plus and go further to VO double plus. Well, finally, okay, it's your turn. Maybe you can try it. Okay, the final one, and pause the video first. VO2 plus and V3 plus. So let me write down. VO2 plus is here, one and only one. V3 plus is here, anti-clockwise relationship. Well, finally, both of them become VO double plus. Again, let's check. VO double plus is also blue, right? So here. So if you got a good training in ECS, I'm sure there is nothing new for you.